weight of an adult man, certainly 7 times 10 to power 2, because weight of adult man is 70 kilogram times 10 acceleration due to gravity. So what describe sets of data with high precision is data repeats that are close to each other, which physical quantity could have unit of Newton second to power 2 meter minus 1. So it is clear that this is the inverse of acceleration unit, so it is force divided by acceleration. This is mass. Ball released from rest, and distance the ball falls and time are measured. Percent are certainty, and distance is negligible, and time 4%. And we want to calculate G. So we have equation of motion, S equals ut plus half at squared. U is 0 because the ball released from rest. So A equals 2s over t squared. For s, it is 0. Okay. And for t squared, it is 2 times 4. So car has initial velocity u, moves with constant acceleration through a displacement d, and reaches final velocity v. What gives us the initial velocity u? So we have v squared equals u squared plus 2as or d. So the expression would be b. A bicycle brakes so that it undergoes uniform deceleration from speed 8 meter per second to 6 meter per second over distance 7 meter. The deceleration constant, which further distance bicycle will travel before rest. So we have initial and final velocities, we have constant deceleration, we have distance. Formula v square equals u square plus 2as is the right one to choose. And as v is less than u, we'll substitute a as okay, we will lift it as it is, 2 times 8 times 7, and after that we can find that this is 36 minus 64 over 14. This answer will give A to be minus 2 meter per second squared. Certainly minus here means acceleration, negative acceleration. And now we want to find the distance. So we will choose the final velocity to be 0, I'll apply this formula again. Initial velocity is what we have reached. Okay, again plus 2 times minus 2 deceleration times the distance s. Here we have 36 over minus 4 to equal s, and s is 9. VT graph, which expression gives the total distance of object, will be A, because we have the motion in opposite directions in area A and the opposite in area 2. Which statement describes weight of object equal to mass multiplied by acceleration. No, because it's not its acceleration, it's acceleration due to gravity equal to resultant force when object falls at terminal velocity. No, resultant force is 0 terminal velocity. Force acting on object due to gravitational field, this is the right one. Which statement of principle of conservation of momentum in elastic collision momentum is constant? No, kinetic energy is constant. Momentum is product of mass and velocity. This is not conservation of momentum. Force acting on body is proportional to rate of momentum. This is the definition of force. So D, momentum of an isolated system is constant. Diagram shows the two balls moving along horizontal frictionless surface before they collide, and they stick together during collision. Which vector represents combined momentum after collision? So we have before collision a movement in horizontal, and here a movement that can be analyzed in both vertical and horizontal. So we cannot expect the momentum, combined momentum after collision to be A, because if we looked here, A is greater than that of the before, and the inclination is towards the horizontal, okay? And we have two horizontal components that opposite to each other, so cannot be inclined more towards the horizontal. It is inclined to the vertical, and certainly this cannot be a resultant for a component in positive y. Okay, it points down, not up. Even if 4 Newton second may be greater than this component, the vertical component up necessitates that the resultant vector to be up, and certainly not D. A skydiver is falling at constant velocity. She then opens her parachute The graph shows the variation with time of hair velocity, which statements are correct. Magnitude of acceleration is maximum at time t2. So to have acceleration maximum, I think this is correct because acceleration decreases after that. So at the beginning, uh, it is maximum, yes. Magnitude of drag force at time t1 equals magnitude of drag force at time t3. Yes, this is true for drag to be equal at t1 and t3 because let us revise the whole motion again. V versus T for a parachutist that falls from a plane. Before opening the parachute, we have a linear increase of velocity and a decrease in rate in this increase because resistance rise up until they are equal, and this is the first terminal velocity. After that, he or she opens the parachute, okay, and we have an increase in air resistance. So there is a deceleration and a decrease in velocity. And as velocity decreases, air resistance also decreases till it equals the weight again. And this is the second terminal velocity. So the graph here is beginning from the first terminal to the second terminal. In both terminal velocities, drag equals the weight. Okay, so 1 and 2 are correct. Okay, magnitude of drag force is maximum at T1. This is not correct. Two different blocks, B and Q, slide together on a horizontal frictionless surface. The blocks have an elastic collision. The diagram shows the velocities of the two blocks immediately after collision, which row gives possible velocities of two blocks immediately before the collision. So we have here frictionless surface, conservation of momentum is applied. We have elastic collision, conservation of kinetic energy applies. Let us write equations to represent these conservation laws. We have V initial MB minus VQ initial MQ equals, this is before, and I choose VQ to be minus because they were sliding to each other before the collision. This equals minus 70. I choose the left direction to be the negative direction and the positive one to be the right. Okay. 70 minus 70 times MB plus 20 times MQ. We can rearrange by getting MB on one side, so it is MB VBI plus 70, and the other side will be MQ VQI, okay, plus 20. Okay, and after that, find the MB over MQ to be VQI plus 20 over VBI plus 70. Okay. With respect to kinetic energy, we have half mb vbi squared plus half mq vqi squared equal half mb 70 squared plus half mq 20 squared. I can certainly remove all these halves and rearrange for mb vbi squared minus 70 squared to be equal to mq 20 squared minus vqi squared. Again, I can find mb over mq to be 20 squared minus vqi squared over vbi squared minus 70 squared. If we equate this part of equation with this part, okay, because both of them are equal to mb over mq, we can make an elimination because this is equal to, if we take minus sign to be common factor here, we have vqi squared minus 20 okay, squared over vbi squared minus 70 squared. This is a difference between two squares, and as it equals, we can eliminate this, and the remainder will be vqi minus 20 here. We can eliminate this with that, and the remainder will be vpi minus 70. Okay, so we have this numerator divided by this denominator and equals to 1. So we have vqi minus 20 to equal vbi minus 70. Okay, which means that vqi plus vbi to be 90. So if we looked for the first choice, 10 centimeter second minus 1 to right, 60 to left, this means that positive 10 minus 60, the sum is minus 50, not 90. Here 50 and 0 is not equal to 90. Here 20 to the left, which is minus, and 70 to right, which is positive. So it is positive 50, again not equal to 90. 60 to right, positive 60. 30 to left, minus 30. So okay, let us repeat again. We will not use the signs here because we used it already in the momentum, conservation of momentum. We use the signs, so we here just deal with the magnitude. So it is 10 plus 60, 70, not equal to 90, 50 plus 0, 50, not equal to 90, 90 plus 70, it is 90, okay? But it can be not to the right, the block Q, and block B not to the left, because the diagram here shows that after collision, Q moves to right, so before should be moved to the left. So the answer will be D. 60 plus 30 is 90. Which diagram shows a couple? So there must be a perpendicular distance between two forces, and this is only here. The diagram shows a uniform bar of mass M and length L resting on a pivot at distance x from end x. An object of mass M is placed on the bar at distance y from pivot, so the bar is in equilibrium. What is an expression for y? So the mass M should be placed here because the rest of the bar will be balanced by the right around the pivot. There is an equilibrium here. And we can apply principle of moment. We have at the midpoint of the bar, the weight of the bar acts, okay, and capital G, and the distance here from the end to the midpoint is L over 2, and from the midpoint to the pivot it is L over 2 minus x. So this distance is L over 2 minus x. We have also mass M small times G, another weight force acts here. So we can equate the clockwise moment with the anti-clockwise moment by writing mg times L over 2 minus x to equal mg times y. Okay, can eliminate g from both sides, and we have y to be m over m small. This can be written like that. So the answer, the mass and volume of an object are varied, which two changes when made together must increase density of object, and certainly increase mass and decrease volume. All level question. On Earth, a solid object that is fully submerged in liquid experiences upthrust UE. On Mars, experiences upthrust UM. Acceleration of free fall on Mars is 3.7. Assume liquid density and object volume are the same. What is the ratio of UM over UE? So we know that U equal rho GV, so U is proportional to G, and UM over UE will GM over GE. So we can say that UM equals UE times the ratio between the two. Okay. Oh, sorry. We'll just divide this by that, and the answer will be a student attempts to derive the formula for kinetic energy. She begins by considering an object of mass m that is initially at rest. A constant force F applied to the object causes it to accelerate to final velocity v in displacement s. Constant force means constant acceleration. Okay. Kinetic energy gained by the object is equal to the work done on object by the force. Which equation does the student not need in order to derive the formula for kinetic energy? So as the work, which is equal to the force times distance, is equal to kinetic energy, we can equate both these sides together, and we know that F equals ma, so we can say that kinetic energy equals m a s. We want to find a. Again, constant force means constant acceleration, equations of motion, and the object moves from rest. We can use this because the question also refers to the displacement s through which the object reaches this final velocity. So a is equal to v squared over 2s, and when we substitute here, we will find that m equal v squared over 2, the formula that we are searching for. And during all of these equations, we didn't use the formula C. Okay, we used the equation of motion, we used W equal Fs, we used F equal ma. A ball falls towards the ground from point X. Point X is 2.4 meters above the ground. The ball rebounds from ground and rises to point Y at 1.8 above the ground. Single value of delta H is used to calculate delta GBE, which is this value, certainly 2.4, okay, meter, and when the rebound was to 1.8 meter, we have the change in delta H to be the difference. It will be 0.6. The diagram shows a block on a slope, constant force of 1.8 Newton in a direction parallel to slope is exerted. This causes the block to move along a slope at constant speed. The block moves a distance 8 meters along the slope. The work done against friction is 4.8 joule and the weight of block is 4. What is the value of H? So as we have the conservation of energy, we have here work done against friction, the 4.8 joule, plus the work, or let me write it like that. The work done by the force, which is 1.8 times the distance along the slope 8, equals the lost energy lost to overcome friction plus the increase in GBE, which is weight of the block, 4 times delta H. Okay, we can easily solve for H or delta H and find the answer. The motor of a crane lifts a load of 600 kg. The load rises vertically at a constant speed of 12 meters per minute. What is the useful power output of the motor? We have power to be energy divided by time. Here the energy gained is 600 times 10 times 12. It is the increase in GBE, less times G times delta H, divided by the time in minute. So it is 60 seconds, and it is 1200 watt or 1.2 kilowatt.